Hello everyone, this is the Math 0332 Notes. I'm Mr. Lee, and this is the end of our percents, fractions, and decimals thing. We're doing percent equations. Now we saw in the third video or so that A equals PB, A is a P percent of B equation, but everything that we saw up to that point was just solving for A. There are different ways to word the problem where they either want you to solve for A, P, or B. One thing to note, if you ever solve for P, it will be the decimal form, and you would have to convert it back to a percent from there. So I just want to look at a few of these to see how they work. What is 5% of 150? So usually if you see a what or a what number, then that means one of your unknown is A or B. Is also the sign of your equal to sign. Is or is equal to equals. So every time you see an is, that kind of reminds you of where your equal sign is. So what will what be the x? X is 5% of 150. So 5% is 0.05. So x equals 0.05 times 150. When you're solving for A, there's really not a whole lot that you need to do. You just need to multiply them. So this requires you to do 150 times 0.05. That's 0, it's 5, carry the 2. 5 times 1 is 5, plus 2 is 7. And you have zeros there. There are two numbers behind the decimal here. So there's two numbers behind the decimal here. So you get that. It's actually the number 7.5 or 7.5. That is actually the one that's 5% of 150. Now this one, we've seen these kind of equations before. But what about ones where other things are unknown? 10 is 25% of what number? So again, the is tells you where the equal to sign. 10 is 25%, that's 0.25. Is 0.25 times some unknown number x. So this is a situation where your unknown is b. When your unknown is b, you do have to do a little bit of work to get it by itself, which means dividing by 0.25. When you take 10 divided by 0.25, there are a few different ways we can look at this. Remember when I said you could add zeros in the denominator to get the decimal to become a whole number in the numerator on a previous video? The same thing happens here too. If I want to move this denominator 2 to the right, I have to add 2 zeros in the numerator. So this is really 1,000 over 25, and we can go from there. 25 goes into 100 4 times, exactly. And then this last 0, it comes down and you just add it here. It goes in 0 times. So you get that x is 40. This actually makes sense because they're asking 10 is a quarter of what number? 25% is a quarter. Well, it's a quarter of 40. If you take 40 and you cut it into quarters, each quarter would be the size of 10. Ones that are also tricky, 23% of what number is 25.3? When you have things with is, they're like equal signs. So this is the same thing as saying 25.3 is 23% of what number? So you'll notice that 2 and 3 are actually asking you the same thing, where the equal sign is kind of opposite. So what I would always suggest that you do is recognize the differences in wording and recognize what makes them similar so that you can solve them. But otherwise, this one says it's the same as the last one. They're saying 25.3 is equal to 0.23 times x. And I'm going to leave that one for you to solve now that it's set up, but I want to make sure that you can practice the division. And finally, we've seen ones where A is unknown. We've seen ones where B is unknown. Sometimes P is what's unknown. So if it says 31 is what percent of 155, then 31 equals some unknown number times 155. And we'll call this x. So that leaves you with 31 equals 155x. When you divide by 155, you actually get that this reduces. They're both factors of 31, so this is 1/5. Now, if you get 1/5 as a decimal, that's 0.2. However, they want their answer in a percent, and we know that in these equations, they always give you the answer in decimal form, so you have to take either the fraction or take the decimal and convert it to a percent. The decimal is usually easier, move it 2 places to the right, so you get that x is 20%. What that really means is that 20% of 155 is that 31. You may also see things like percent increase or decrease. A percent increase is when it increased over the old value, and a percent decrease is when it decreased. Generally speaking, I like to call the percent increase decrease equations the new total or new value minus the old value in the numerator and then divided by the old value. So if 10 is increased to 15, the increase is what percent of the original number? So our new value is 15 and our old value is 10. So 15 minus 10, all divided by 10. So that's 5 over 10, which reduces to 1/2. Most of you notice 1/2 is 50%. So this is a 50% increase. If it goes up, it's an increase. Namely, if this is positive, it's an increase. If it's negative, it's a decrease. However, the percentage will always be positive, and you'll deal with the negative or positive in the wording afterwards. That's what brings us to number 2. If 10 is decreased to 3, the decrease is what percent of the original number? This is our new and our old. 3 minus 10 over 10 is negative 7/10, which doesn't reduce. Now, if we do this as a decimal or a fraction, this is negative 0.7 or negative 70% as a percentage. The way that we would call this, though, is this is a 70% decrease. The negative shows us as a decrease, but you don't call it a negative 70% decrease. The fact that it's negative is taken care of by calling it a decrease. And that's the most important part for these problems if you come across them. And really though, besides the A equals PB equation and percent increase and decrease, that's really all that's on the homework 5. Like I said, a few of them, homework 3 and 4 have a few questions like the top here. But otherwise, that's it for percent equations, and that's it for Unit 4.